Deer Creek Audio, your trusted technical resource.
Looking for accurate, ultra-deep bass in your home theater? Do you want to optimize your experience by adding multiple subwoofers? In this video, we will help you do just that by walking through the process of setting up a multi-subwoofer configuration for a home theater using miniDSP device console and a 2x4 HD or Flex. There are several ways to configure multiple subwoofers in your home theater. The basic concept is to combine them into a single virtual corrected subwoofer. Using this method, you will calibrate the subwoofer group independent of the audio-video receiver or processor. Next, you connect your subwoofers through the miniDSP to the AVR, where they appear as either a single monaural group or a left and right pair. We will also explore approaches for AVRs with multiple subwoofer outputs. Then you can apply your home AVR correction process, such as Odyssey, ARC, Dirac, or YPAO, to your entire system. Subwoofer placement is driven by the number of subwoofers in your system, listening room configuration, and aesthetics. In general, spatial diversity is preferred. You'll need to temporarily connect the audio output to the miniDSP using USB. REW test signals generated in your computer will be used for frequency response testing. The direct USB connection approach is ideal because we are calibrating the subwoofers as a single virtual subwoofer, and then later connecting the miniDSP to the AVR through analog cables. Be sure that all of your subwoofer cables are of good quality, adequate length, and securely connected. We recommend using USB Revision 2.0 cables. At this time, you can check that the built-in level, equalization, inversion, and crossover frequencies of the subwoofers are either bypassed or set to nominal. Your subwoofers should be set as shown, so they won't interfere with the crossover, gain, and delay parameters that will be set up in the miniDSP device console. Generally, subwoofers can be placed against the front wall near the front left and right main speakers. Before proceeding with tuning, it's a good idea to experiment with various subwoofer positions and orientations, depending on aesthetics and room limitations. You can use REW to see the effects of the changes in position. Regardless of where the subwoofers end up, their location can be compensated for in a multi-subwoofer system by adjusting the equalization and relative delays. Your subwoofers can be driven monaurally, or as left and right, or as a combination of monaural center, left, and right. If your AVR only has a single subwoofer output, then your configuration will be monaural. In this example, we show 3 subwoofers that could be front left, front right, and a center rear. This also can apply to 2 or 4 subwoofers. If your AVR has left and right independent stereo outputs for the subwoofers, then you can configure them as such. In this example, we show front left and right subwoofers plus rear left and right subwoofers. This example is for an AVR with independent left and right subwoofer outputs. This could be left and right stereo subwoofers with a monaural center subwoofer. Here, we show a routing matrix with left and right stereo subwoofers and 2 rows of actively driven bass shakers or butt kickers. You gain several advantages by using a miniDSP for bass shaker integration. First, you can use standard high-power amplifiers. Second, you have the flexibility of the device console configuration platform. In this next section, we will show a compatible crossover. Setting the optimal crossover frequencies is critical to achieving the best overall system performance. Depending on the size of your main speakers, you can determine the frequency and slope of the high-pass filter your AVR will be applying to your main speakers. You can choose a matching low-pass frequency and slope for your subwoofers, and then later experiment with different slopes and overlapping or underlapping frequencies. We recommend adding a 10 Hz or greater high-pass filter to the subwoofers to eliminate unnecessary driver excursion and load on the amplifiers. If your subwoofers have differing frequency response capabilities, you can set high and low pass filters that will focus amplifier power to their useful frequency range. In this example, the subwoofer filter in gray was chosen for a corner horn speaker that did not have useful frequency response below 30 Hz. Bass shakers or butt kickers can add a lot of intensity to your home theater experience. Here, we have chosen a frequency range of 10 to 35 Hz. This applies power to the useful range of the shakers and also eliminates annoying audible output above 35 Hz. You'll need to confirm that the subwoofers are in phase with each other and in phase with the rest of your home theater speakers. This ensures that you'll get the most accurate and highest power output across the frequency range. First, the left and right subwoofers are measured individually. These are the red and green lines. Next, the left and right subwoofers are measured simultaneously. The blue line shows there is 6 dB of gain when they are summed. If the subwoofers are out of phase, they will be subtractive. We can now verify that the subwoofers are in phase with the full range speakers. If you have an inverted phase situation, the level will subtract in the crossover region of the drivers. The goal is to end up with all of the speakers being additive in power level. The time of arrival of subwoofer signals needs to be equivalent, so they will be additive in power at the main listening area. Using physical measurements for determining the delay offsets from the various subwoofers to the listening position requires the subwoofers to be the same design and have equivalent near-field latency in phase. First, calculate the individual subwoofer delays as follows. Measure the distance of the subwoofers from the main listening area. Calculate the difference in distance of each subwoofer from the farthest subwoofer in feet. Find the delay in milliseconds by dividing the distance in feet by 1.11. Finally, enter the resulting figures into the corresponding device console delay fields. You can also make delay calculations using the electronic method with REW. For more on this process, check out the tech blog on our website titled Using Delay Settings to Integrate Your Audio System. Now, we will apply an REW room correction filter to a device console PEQ bank. The blue line represents before REW equalization, while the red line shows the corrected frequency response. This example is for one subwoofer. Each subwoofer can be calibrated independently by making a sweep and then going to the EQ page of REW to generate the correction filter. REW calculates the filter coefficients, which you then download into the PEQ menu on device console. You can find more details on how to perform this correction in the REW help guide. Next, you will adjust the relative levels of all the subwoofers to be equal at the center of the main listening area. Using the gain settings, you can achieve equal subwoofer levels and set a level that will be compatible with your AV full-range speakers. At this point, the basic setup is complete, and your virtual subwoofer is ready to be connected to your AVR. We recommend you perform a full hardware reset on your AVR, and then rerun room correction on your system. This will apply your AVR home theater calibration and integrate your precisely calibrated subwoofer group. After you have completed your AVR room correction project and are satisfied with the results, you can use Device Console to adjust the PEQs manually. You can have up to 4 tuning curve presets for different types of movies and music. Be sure to visit us at deercreekaudio.com for more resources, tech blogs, and product details. Keep watching our YouTube channel for more video releases.